We're going to look at 23 and as well as 26 and 27, which are all sine graphs. The first one asks you to write 3 different equations for the graph pictured at right. So I'm going to start with a piece of tracing paper that has the equation y equals sine x on it. And we're trying to write an equation y equals a sine x minus h plus k. A controls the stretch or compression. H controls right or left. K controls up or down. A also controls whether the graph is flipped upside down. So in this case, the reason why there's multiple equations is because we can match this y equals sine graph up with any portion of the transformed graph. So one possible part of the graph I can match it with is over here. In that case, I've moved the graph up by 1 unit. So that would be a k value of 1. I can also move the graph left by pi over 2 units. So h would be negative pi over 2. So up by 1, left by pi over 2, and the graph has not flipped upside down or become taller or shorter. So a is just equal to 1. So y equals 1 sine x minus h becomes x plus pi over 2, and then plus k. So let's look for 2 other possible equations. This first equation matched the graph up over here. So now let's try to match the graph up over here. So we can move the graph up by 1 again, and then right by that many units, which would be this mark. Halfway between pi and 2 pi is 3 pi over 2. So again, we went up by 1, so k equals 1, and right by 3 pi over 2, and the graph matches up. So h is 3 pi over 2. So y equals sine x minus 3 pi over 2 plus 1. Now let's see if we can introduce a flip of the graph and try to get the graph to match up. So I'm going to try to flip the graph upside down. That would be an a value of negative 1. Then from there, I need to move the graph. If I want to try to match it up with here, I need to move the graph up by 1 unit. So k equals positive 1. And right by pi over 2 units, which is this mark right here. So h is pi over 2. So y equals a is negative 1 sine x minus pi over 2 plus 1. Now in 26 and 27, you're given an equation and you're asked to sketch the graph. So I'm going to again start with y equals sine x and move the graph accordingly. So in this case, the negative flips the graph. The minus pi over 2 shifts the graph right by pi over 2, and the plus 1 moves the graph up by 1 unit. So let's flip the graph upside down, move the graph right by pi over 2, and then up by 1 unit. So that is the resulting graph. So we're going to start right there at pi over 2, 1. This is going to be our midline of the graph. It's going to go below that line first, and then above that line with a height or an amplitude of 1. Alright, then number 27, the 2 is going to make the amplitude twice as big. So the amplitude is 2. The plus pi is going to move it left by pi. So in this case, if I go left by pi units, I get there, but the graph's going to be twice as tall. So instead of reaching a height of 1, it's going to reach a height of 2. So at negative pi, I start the graph. It's going to go up to 2 and down to negative 2.